So let's start. Today's our first lecture about the geometric intuitions. It is about geometric intuitions of logistic regression. So first we discuss what is the geometric logistic regression. So let's start. So the main task of the logistic regression is about classifying. But why we call it that is regression? This is the main matter. So first, as we see in that it is the logistic regressions. But our main objective is this regression is about classification. Okay, and this classifications algorithm is all about simple and elegant. So as we know, the neighbor based classification is algorithm is based on probabilistic approach. All about probabilistic approach. But the logistic regressions behind the intuitions of the logistic regressions is the geometric intuition. Okay? As we saw, we write it as logistic regressions as and it's geometric intuition. So we discuss this lecture as three parts. So the logistic regressions we first discuss is all about three parts. So we first discuss the geometric intuitions of this logistic regression. Then we discuss what is its probabilistic. And finally, we using loss function, we discuss about the logistic regression. Okay? And here in probabilistic intuitions, we have seen some references of this regression method. This is the main agenda of the logistic regression. So the main task is the classification. So let's start. Our set of points is two types, that is positive points and negative points. As color changes, we write the positive points as a white color. This color is all about positive plus point. And here we taken the green color as negative plus point. Okay, now draw the pictures. So first we write down the taken some data points, the negative plus points. And now we take the some arbitrary random data points as positive data points. Okay, so now our main target, main objective is have to find some plane that perfectly separates the two planes, that is 2 points, two data set of data points. Now main objective is to find this plane. The main objective find this plane that is perfectly separated these two type of data points. Okay, this is the main objective. So the main assumption is this point is that the two type of data points is linearly separable. This is the main assumption of this regression process. So if my data points is linearly separable, or this is linearly separable or almost linearly separable. Okay. So as you know, in 2D we call it line, in 3D we call it plane, and or ND we call it a hyperplane. In 2D we call it as plane, sorry, as line. In 3D we call it as plane, and in higher dimension, that is in ND, we call it as hyperplane. Okay, so these are all our linear surface. This is all about our linearly surface. So as we know, in basic class, that is in 10th or 12th, we know the equations of the line. In 2D, the equations of the line, it is represented by y is equals to mx plus c, and in higher dimension, this line is represented by, so here we have called this line as pi. In higher dimension, this plane is represented by w transpose x plus b is equals to 0. So main the objective is, we know the x is our data point and what is all about w transpose and b. So nothing, w transpose is nothing, just it is the perpendicular to our plane. We call it as w, and b is the interceptor. B is what? B is called the interceptor. Okay. This is all about the plane of the higher dimension, where x is our data points, w is our perpendicular to the plane, is w is the w transpose is the perpendicular to the plane, and b is the interceptor, is equals to 0. And it is the basic mathematics how a higher dimensional plane is written as mathematical. So if the plane which passes through origin, then what is about b? Simply, if the plane is passes through origin, then the b is all about 0. If the plane is passes through origin, this plane which passes through origin then b is equals to 0. So in such cases, what is the equations of the so in such cases, what is the equations of our plane that is in higher dimension, that is in n dimension hyperplane? So in such cases, the plane equations is the plane equations, that is pi, is simply written as w transpose x plus b is equals to 0. This is r is equals to b, so simple. Now these equations can be written as w1 to 0 when it is passes through origin. But again, we have to remember one thing. So let us say our data points, that is here we call x, that is belongs to the n dimension. I think you all know about the primary of linear algebra, so we, to save our time, we omit this kind of, okay? Just we follow our main objective about the logistic regression. So let the data sets which belongs to n dimensional. What about if the data set, then w is also belongs to n dimensional. So what is all about w transpose is all belongs to dimension r. Since this is dimension is then is transpose, and which multiplications with n dimensional point is all about belongs to r. So the interceptor, that is b, also belongs to single real number, that is these two things are all about scalar. Sure, now we know every model is have some limitations. Big what is for limitations? Because we assume something. So for our assumptions, this is our limitations. So our assumptions here, what is our assumption? So let's take our color is so assume the classes are almost, yeah, perfectly linearly separated. Most or perfectly linearly separated. Okay, this is our the assumptions. So what is about all our assumptions of the Navier-Weiss equations and the k neighborhood k-array equations? This is also the classifications algorithm. We know what is all about our Navier-Weiss equations assumptions. This equations assumption is This is the main assumption is the features is linearly independent. Features are all about linearly independent. Sorry, we cannot say it is linearly independent, means simply it is independent. And what is about the KNN? And main assumption is a neighborhood. That is, our data points is the same as our neighborhood. That is, our average or maximum number of neighborhood points is all about our data point. It is the main. The main. What is the main assumptions? Okay. So again, we remember our objective. What is our objective? Our objective is here we have a plane that is pi. What is the equations of our plane? Is W transpose x plus b. What is main objective or given? Here given is the data points, that is we call it as train data and test data, that is simple data point, we have called it as DN. So there are the two type of data points, that is positive data points and also negative data points. Here we have given are the main tasks. W, that is what is the perpendicular of our plane and what is the intercept. This is the main task. That is pi. Simply, if we call it at language, we have to find it W and B, means we have to find the best separators that is separate between positive points and negative points. Is we have to main task. If we write it in literature, the main task is all about pi, that separate best positive points from our negative points. Okay. Now let's talk about the main mathematics of this. So as we see, as we here see, what do we have see? Here see that our model is linearly separable. So let's redraw our positive data points. This is all about our positive. This is all about okay, and this is and this is here called pi. This is our perpendicular to the plane that we call W. We have to find it. At least at the end of the day, we have to find this W and B. So now let the distance of any point, suppose we call it as xi, Suppose this point is we call it as xj. So from distance from the point to this plane, let this point is all about di, okay, and the distance from this point all about dz. So this is our any random arbitrary negative point. This is any random positive point. So this distance is di and this distance is we call as dj. So what is from the equations? What is the distance di from the plane? Mathematics. This is all about mathematics. If you forget it, I request you please go to the internet or anywhere, any kind of mathematics primary basic books. You can find the formula. What is the distance of a point from the plane? So this is all about di. Distance is w transpose xi divided by norm of the w. So what is w is the normal to the plane. We let, because w is the normal to the plane, because we let the normal is all about unit vector. Hence w is the normal to the plane what is this w. Norm w is equals to 1, right? Because this is the unit vector. So the main distance will become w transpose x. Okay. So the what is all about di. If di equals to w transpose xi, if the point is the same direction, if the point is same direction of the direction of w, then what is all about di? Then di is positive. And if the data points, that is xi or xj, is the different direction, that is opposite directions w, then the direction di is all about negative. So as you taken the two random points xi and xj, the opposite sides of the plane, and the w is the that directions of the xi. So the di distance will be positive because wi and xi are the same direction, because w and xi are in the same direction. And dj is equals to w transpose xj is negative. Why? Because w and xj are in the opposite direction. Okay. So the classifier main tasks, if our w transpose, that is gi, w transpose xi is greater than 0, then our yi, that is our class level, is positive, otherwise it is. So let's take with if else condition. So our, if we write down the code as any languages, what do we have right there? If w transpose xi greater than 0, then yi plus 1. So here plus 1 and minus 1 we have written to denote the different class level. Okay? So don't be confused about what is about plus 1. We have discussed everything next of this. What is about plus 1 and minus 1 just to denote the different class level. Okay? If w transpose xi is less than 0, then it is the another class level and we denoted it minus 1. Okay, this is on surface LR, line or plane. If the decision surface is all about. Now we have seen here 4 type of cases. So let's discuss one by one. What is? So first discuss all about. Just we write down the DRG matrix as of simplification. Here this portion fault is our classifier. That is our given classifier. Class level. So let's one by one. So first our given yi star our w transpose xi. So it is better if we write down the class level and classifier. It is right. W transpose x. It is better. It will be positive. That is, we write down is greater than 0, less than 0. It is two type of different classes, that is positive plus and negative. This kind of 4 situations. So let's start. If our yi, let's take our yi is positive. Okay, and it is positive one, and multiplications is greater than 0. Total multiplication greater than 0, and this is the positive. So when it is occur, when these situations will occur, simply yi is equals to plus 1. Let's we discuss about why we call it taking at plus 1 and negative plus minus. Just bear with me, just patience with me. We discuss everything. Okay. So if yi is equals to plus 1, then it is what? This is positive point. And when this multiplication will arise positive, if w transpose xi greater than, then only then it will is positive, and if it is positive, then the multiplication will be positive. So classifier is saying is the positive one. This means what? Classifier is saying is the positive one. And what we have same if this is positive data points and this is all about positive, means what? The classifier and W is correctly classified. So just see in this picture, means our this is the positive data points, this is the negative data point. Okay, if W, when this one is the in the same direction, if this one is greater than W and X if the same direction, then the multiplications is greater than 0. Okay, if the different directions, then the multiplication is less than 0. So if yi is positive and our classifier is greater than 0, that is our given x data points and in the same directions of our. So classifier is all about saying. Classifier saying in the positive point. So means W is correctly classified here because our point is positive and our this one says that our directions of the W and is the same directions. So W is correctly classified. Now let's take case 2 point. What is all about given data points is negative. And our less than 0 means what is saying the logistic regression saying that the normal of the plane and the data points are in the different direction. Okay, consider the other negative points. Different directions means our negative points. Okay, Simple. Different dimension is negative points and similar dimension positive. So now what is the multiplications of these two terms? Now this is the negative, this is the negative. This is all about greater than 0. We have chosen the point is negative points, and our also logistic regression concludes that our points also about negative points. So multiplication of two positive points are greater than 0. So first here we have seen that also here we have seen that if this multiplication positive in W is also correctly classified, here also correctly classified. So if correctly classified, that is, but when the correctly classifier is this one is the positive, this one and this one is also, these both situations our multiplication will be positive. These two diagonal elements is also correctly classified, and here the two diagonal elements are wrongly correct. And so now let's see what is about if we classifier is given that is wrongly classified. So let's consider the history and for example, if suppose if wi is equals to +1, that is positive point, and our classifier given that negative, that is what is all about. So our linear regressions is saying that xi is negative plus if the direction of the W and the direction of the data points is the same direction, then only these will be positive. If totally different direction, this is only the negative. So as we assume that our directions of the W is in the direction of the positive data points, but here also given that it is negative, that is xi, the given data point is negative plus, but our classifier say that the given classifier is the positive one. Totally the wrong, different. So the in such cases, what is the multiplication? Is multiplication is all about positive negative, that is negative. So our data point is positive and our Ligrian regression is saying that it is negative. Okay, so what is misclassified? In such case, it is misclassified. So let's take them on the last case. Let's take is the negative point. Okay, and our logistic regression is all about saying that is x transpose xi is greater than 0. Means what? Means this is the positive data points. This implies logistic regressions. Our logistic regressions is saying what is saying that xi is positive data points. So in such cases, our given data point is negative. Actually, it is negative, but our logistic regression is saying that it is no, it is not negative. It is positive data points. So totally misclassified. In such situations, it is totally misclassified. Okay, so we seen that both, if we totally observe that one thing, if our correctly classify, if our case 1 as case, we have seen that case 1 and case 2, if our data points is correctly classified, then only then the multiplication of yi into the w transpose xi is positive. If it is misclassified, then the multiplication result is totally negative. Okay, so if the multiplication is totally misclassified, then this point is negative. So the final, if we assume the final conclusions about this model, so what, why, when our the model is good? Classifier to be very good. When the minimum number of, we want to minimize our misclassified point. Sorry, I'm just reading. I'm minimum number of misclassifications. Want to minimize our the minimum number of misclassifications, and same the opposite directions. We want to maximize the number of correctly classified. Okay, we want to minimize the number of misclassified point, and we want to maximize the number of correctly classified. So what is all about mean? If when it is the correctly classified, it is correctly classified, then when multiplications of yi with w transpose xi is greater than 0, then we have shown, they have seen when it is the correctly classified. If the multiplications of yi with w transpose xi is positive, then only it is then it is only positive. We want to maximize, so we want to maximize this term at the final, at the end of the day we want to maximize this, that is we want to maximize this when the multiplication result is positive. So if we write down that is matrix term, at the end of the day we want to find maximum the result in summations of the all points I is equals to, suppose, to n, when n is the number of data points. Want to maximize, and here what is the variable and what is our known terms? We know that this xi and yi, we know this term, we know that this term we have already known. This is the our known term, and sorry, and this term is only our variable point. This is only, w is only variable, we don't know, we want to find this w. As previously discussed, we have discussed already in previously that w, we want to find the w and b. This is the main task. End of the day we want to find the w and b. So, and we assume that the plane is going to the origins, and if it is going to the origin, then the b is 0. We have seen if the plane is going to the origin, then B is 0, then only the rest of the term is W transpose B. So as in the simplify of our calculations, we have taken the plane is line is hyperplane is going through origins. So just work with W transpose. Okay. So at the final day, we want to find the W. What is all about W? What is all about W? We want to find this. We want to find this term W, and it is the variable, and we all known about this term. So if we finally write down our n data points here, we have n data points. Okay. We have n data points, and our in such cases our xi and yi, this is the fixed. This is the fixed. Actually, this is the known term. For this reason, this is the fixed. Okay, and our variable terms only this. Actually, if we are about these terms, this term is coming from our the training data set. Okay, this term is all about coming from our train data set. Coming from train data set. And we have to find the W, which you have had. Just at the end of the day, what I'm writing? At the end of the day, we write a total equations at the end of the day. We have to find the W star. It is all about argument maximum. Sorry, this is the maximum term. Maximum term. Argument of this maximum is all about summations I is equals to 1 to n yi W transpose. So here this term is we called the variable. This is all about optimal. This W transpose is about our optimal W. This is our final day equation. This is our mathematically optimization problem. Okay. So okay, I think the geometric intuitions is all about clear. So just revisit our lecture. What do we have learned? So we have learned the first, we have assumed something, and according to that assumptions we have built our logistic regression. The main assumptions is that our classifier is all about linearly separable. Okay, this is the main assumption, and according to that we have built it. So what is about geometric intuitions of the regressions? Yeah, classifier model. Our geometric intuition is that our first we have taken some directions of the W. Okay, W is what? This is the perpendicular from the plane. Okay, this is the perpendicular. This is the W. This is the perpendicular of the plane. So suppose let's take the W directions of the W is the same directions of our positive points and at the opposite direction of negative. If it is the same directions, then the multiplications of the data point, that is xi, and that is the the multiplications of the xi is the positive with wi, the multiplications xi with wi is positive, it is the same direction. So let's take the directions of the w is the positive direction of the positive data points. So the multiplications of the positive data points with w is positive and the multiplication of the negative data points with w is negative. So this is the first calculations. According to that, we have arranged 4 cases. So our given class levels with our we have compared the given class level with our calculated class level. Calculated class level means what is all about logistic regression says. That is what is about logistic regression say means what is about the multiplication says. That is w transpose xi. If multiplication same, it's saying that it is same with the original class level, then it is the actually it is the perfectly classified. So in such cases, we have seen that the multiplication here is positive. If it is saying that now our logistic regression saying it is not the same direction, it is totally in different directions. So in such cases, we have seen that our multiplication result it arise negative, but our original class level is saying it is also positive. So in such cases, the multiplication we have seen that in such cases multiplication is negative. Okay. Add with table from the table, it is actually miscalculated. This is our logistic regression saying it is positive plus original class level is negative. So in such cases the multiplication is negative. And if our class level saying that it is positive and also classification saying that it is positive, then it is positive. So in that final day, we have taken the two conditions. If the classifier is all about correctly classified, then the multiplication is all arises only positive. Otherwise, actually at the final, we want to maximize our this multiplication. We want to actually maximize our correctly classified. If we want to maximize our correctly classified point, so our mathematical objective will be the same. That is, I want to max this problem. That is summation of y w transpose xi. We want to max this. Okay, so and we know already the value of xi and yi. It is coming from our training data sets. Okay, and only variable is the w transpose. Actually, it is assumed that it is the same direction of w. At the final day, we want to find it, and b also find it because we want to, as previously saying, we assume that our plane is passing through origins. So here b is 0. So just we want to find the w. Okay, so this is the main mathematical optimization. Okay, thank you. Let's see